Alright. To make a tangent line, we do y equals, I guess we did this way, right? Y prime of 0 times x minus 0. You guys agree?
Mm-hmm.
Yeah.
Careful.
Yeah. Equals.
Plus y at 0. True? Because y minus y1, I need to add the y1 over there. So then y is equal to derivative of sine is just cosine of 0, and I have x minus 0, and then what is sine of 0? Got it? So I get y equals.
Oh.
Okay. So my tangent line. Remember, for slope you gotta plug into the derivative also. It's not cosine of x, it's cosine of 0. Cosine of x at 0. And then if we were to graph, question, how long, or for how long, or for what interval, will a tangent line approximate a function?
At one point.
Well, you can approximate it for like pi over 2. But
You
the
can
further
approximate it up to infinity.
The further you go.
You can approximate it forever. Where would it be a good approximation? For what interval approximately?
About right there.
Somewhere within negative pi over 2 to pi over 2. It should be a pretty good approximation. If we were to zoom in, doesn't sine kind of look linear for a little bit?
Yeah.
Right? So not just one point. I mean, if I was to do this tangent line at pi over 2, how long would that be a good approximation?
Not much.
Not for long, right? Because right away it starts diverging pretty clearly. But this one maybe from negative pi over 2 to pi over 2, maybe negative pi over 4 to pi over 4, but for a little region, right? Okay. Is there any better way to approximate sine besides having to make tons and tons of tangent lines? As soon as you get to pi over 2, let's move it. Well, that didn't really help. And then just keep on moving the tangent line? We could do that, but is there another way? First, would this be an over or under approximation of sine of 0.2?
Over.
Why?
It's above the graph. In this first quadrant.
Over approximation since that one's my first quadrant. Say it again. I might have just missed it.
What?
Why is it an over?
Because you said first
When you look
quadrant.
at the graphs, it's first
It
quadrant.
goes x,
What?
the graph,
Hey.
y2 is greater than y1. Is it because it's concave down?
Since sine of x
Good job, Gabby.
is concave down at x equals 0.2. How do we tell when tangent lines are over or under approximations? Concavity. Whenever I have a concave up, a tangent line will always be below. If I have a concave down, a tangent line will always be above, right? Over approximations, under approximations of tangent lines, concavity. Ooh, that's always been a card I want to add. This year, I think I'll do it. Oh, now my orientation's all off. Give me one second.
You're forgiven.
Kiddos, what happened in your calculator? How cool does that look?
Very
Kind of nice.
Crazy.
It introduced you to the idea that tangent lines are probably one of the worst approximations?
Those are actually nice.
Yes, it did.
I did. Look at your guys' calculators over there. Okay.
Shame.
So what happened? You guys put it in. And what did that graph end up doing? As we go one, then the next, then the next. If yours are all graphing at the same time, that was my tangent line. That was my cubic. That was 2 terms. There's my
Quintic.
quintic.
Quintic. Oh,
That's my 5th degree.
septic.
There's my
Septic. Right?
septic.
Is it
I know.
non-tic? Is it non, right?
Non-tic.
Oh no! That was so anticlimactic.
Oh, wait, that was solid.
Climatic, no it isn't. I don't know.
Yeah.
Quartic, quintic, climatic.
Do you guys see from these, now it's taking a little bit of time, but do you see slowly the sine curve being formed?
Yes.
Pretty cool, huh?
Thank you.
So what would happen if I keep on adding? I'll get closer and closer, but also,
Why is the line so thick?
Oh, wait, it.
I made it thick so it's really obvious. There's my sign. It is going to get closer and closer, but here's my question. does it eventually need to diverge?
Yeah.
Just by nature of a polynomial, isn't it going to always be going to negative infinity and positive infinity? If it's even going the same direction, if it's odd going opposite directions, right?
Mm-hmm.
So I'm always going to have that dilemma. But the point is, as I keep on adding more and more and more terms, it's going to converge for wider and wider and wider distances. True?
Mm-hmm.
And converge for longer than a line would. Now, for what interval? Ooh, wait, what? For what interval? What am I talking about? Interval of convergence? Interesting. That's something we still have to kind of work with. Now, the ones that we saw on Thursday and Friday all had to do with geometric series, true?
Yes.
Quick dilemma. Did you guys write down your 10-1 homework on Friday?
Yeah.
Okay, yeah, never mind.
Wait,
So that 10-1 homework, you guys were dealing with fairly basic geometric series, but being applied to new things. So whenever it was asking for, in our notes, the interval of convergence, what were you always able to build off of? For geometric series?
The R.
The R, right? Because we always know for geometric series, R is in between -1 to 1. So in all of these where you were just multiplying by a common ratio, we could always find interval of convergence. Dilemma is on sine. Kiddos, look at his series. Is that a geometric series?
No.
Is that a pattern? Yes.
Yes.
Is it geometric?
it's a
No.
Taylor series.
It is a Taylor series.
Oh, I'm so
Well,
sorry.
Taylor's polynomial, but yeah. So, interestingly enough, this is another infinite series that is going to approximate sine. Our question is for how long or for what interval, and that's something we still have to answer. They had you go ahead and try to think of what was at 0, at 0, at 0.2. What happened, at 0? Can you guys all tell that everything crosses at 0, 0? Okay, so no big deal. What if we were to plug in, what was the next one, 0.2? You guys know the shortcut for doing the value, right? Just hit the trace and type.
Yeah.
So 0.2.
No, I do.
Okay. So my y1, I think, is that my tangent line? I assume so. At 0.2, I have 0.2. What if I go to the next one? I go 0.1903.
That's normal.
0.190. Wait, do you see any difference between
No.
sine 0.19032124, 0.19032124, 0.19032125?
Whoa.
How close are those stinking approximations?
They're really kind of close.
By the micro.
I'm getting more and more and more precise. Now, we can't see all the decimals. I kind of wish we could. That'd be a little bit nicer. But anyway, long story short, better and better approximations for longer and longer. Sure? Okay, here we go. Taylor polynomials, section 10.2. 10.1. You need to grade and have it ready to grade. We're missing a few, we're not missing a few. Let's get into 10.2 and then we'll see. If we have a little bit extra time, or I think we've done a good job of introducing, then we'll grade. Otherwise, we'll grade 10.1 tomorrow. Sound good?
So will the 10 be due in 2 hours?
Oh, I'm looking. Sorry, let me make it bigger. I did not mean to leave it that small. I apologize, guys. Oh, what? There we go. Okay, shush, shush, shush. I'm checking the calendar real fast for homework numbers and due dates. It is February? That's good.
Because I may, I'll have been done with all my interviews. I'll be good to go. No. It's not really.
I'm asking what how serious is.
Well,
Yeah, it's kind of cold. So.
You can close the door, guys. That's
finish
totally
the
fine.
interview pretty soon. I think I'll improve the show.
Yeah.
Did you jump in? I should have met that.
Okay, but I just realized.
No, she's not. She's.
That's
there. Yeah. She prompted you.
All of the schools that have to see that finish this, guys. Can you go check for printout, please? Thanks, Ben.
Are you guys got it?
No, not every year.
I'm just
No, but they
Okay, but I think it's gonna be due on Friday. Yeah. There's a lot going on in this section.
Right, Gabby? Stay on my chest.
We have this one and then kind of one more. Yeah, kind of one.
What do you mean?
You're really comfortable.
Is that a secondary?
Let's have a rap battle like that.
A math rap battle?
Yes.
Rap out, you're right.
Okay, you guys good?
I'm not.
I don't know why it's taking me so long. You have nothing to write in all the time.
So you have to tell Charles. Oh, that's cool.
Why do you think of five
I'm already done with this. I want to see if I got it or not. I didn't go to college or that.
I'm so confused.
Well, she has
That's
that
how
green, I
it
think.
Oh yeah, is it possible to get accepted, but they don't tell you that you got accepted, but then they tell you about housing plans?
This is possible.
It's like,
They sent me email.
they were like, congratulations on being accepted. I don't remember getting anything that said I was accepted.
Sit down. Maybe on your portal.
Yeah.
Maybe you check your portal.
Yeah, I did, that's why, it's the issue.
So Ethan's gone, Dylan's gone, Emily's gone, but I keep sending you being accepted.
Dang it, I hate it.
Well, and actually, have a little view of yourself. But seriously.
Okay, if anybody finishes early, can you guys figure out the Endeavor numbers for me?
I got you. I think it's 24 and 25.
Don't worry, it's 24 and 25.
Well, I already got
I'm
it.
gonna ask girls.
So,
Come on, contest.
it's always contest. I thought up. I gotta make sure he's engaged. I want to make sure he knows that we don't
Probably not
forget.
even gonna listen to it.
Probably, but who knows?
I'm going to it.
Sorry, that was AB's
Most
numbers.
people Dylan shout out. Ethan shout out. Dylan shout out.
Miss D, do you keep the videos from last year, so like if we were to scroll
And Alan
back,
shout out.
so we can
I
see
already said
listen to
that.
your
I said
your
that.
very first ever video,
The first ever what?
your first ever like,
Oh, I wasn't recording that long. So I've been recording for 4 years?
I do that one.
I don't think I was doing the same thing on the YouTube channel either. For a while, I was
This
uploading it to Google Drive and it was awful.
Did you know Miss Chang makes on the YouTube channel?
Is he racking those views? Racking those views.
20 mil.
Hey guys, what does the N stand for?
Number. The number, the term of the series.
The Nth term, okay, so what's the N stand for when it's in the superscript of the F?
The derivative of power.
Nth derivative, right?
And derivative?
Nth derivative. Because it's F prime, F double prime, F triple, quadruple, whatever, F, the Nth derivative of F, just making sure we're good. Just making sure we're good. A power polynomial is where we can just go ahead and multiply by x every time. Or I should say power series is where you just keep on going increasing powers of x. So I'm not saying this isn't, I like keeping power series totally separate. We have to realize that this is different than geometric series that we were seeing before, and mostly for the reason that I was saying as far as the interval of convergence and how geometric it's only r between -1 to 1, it's only for a set region. These ones, the interval of convergences, we're just going to cover totally separate because they are not geometric in nature anymore. But they still do follow a very distinct pattern, and a distinct pattern is interesting. Wait a minute, hold on, with that sign that we were doing, we took the derivative when we did the tangent line, right? Hold on, wait. Where's the tangent line in this? First of all, it'd be the function equals just a value. That's not really a good tangent line. But wait. Didn't we say that y is equal to y of 0 plus f prime of 0 times x minus 0? Wasn't that a tangent line, just those two? Interesting. So all this time we called it a tangent line, we could have been calling it a second degree Taylor polynomial? Ooh, that's
Tangent line is much shorter.
It is much shorter and it makes a lot more sense. But how do you build on the next and the next and the next and the next? Well, hold on, pause. Let's go back to that sign and see if it makes sense. Who is this guy? If we were to follow that Taylor polynomial formula, right? In order to form sine of x, now hold on. The polynomial is equal to this entire thing. But the problem is this is still, now you might want to write it, you might not want to write it, this is still only going to approximate the function, okay? The Taylor polynomial is still only an approximate because the nth degree Taylor polynomial in a sense has an end. The nth term is the end, there is no plus ... This isn't a series, this is just a polynomial. Coming back over here. So sine of x I have to say is approximately, and I could say, let's see, this would be p sub 7 of x, the 7th degree Taylor polynomial. And according to that formula, how we start? F of c when c is where it's centered at, and guys, where are all of these centered at?
0.
Okay, so we centered all these approximations at 0, and that was per the direction on this board, right? It said at 0. Find the tangent line at 0. So I'm centering at 0, so I'm going to have f of 0. How does the Taylor polynomial go again? Plus f prime of 0 all over
Wait, this is centered on 0, so.
times x minus 0, right? Which would just be x. What would the next term be?
F double prime.
F double prime of 0 all over 2.
2 factorial minus x squared. X squared
Now, we're just going to do this ... for right now, see if we can find a pattern, because if we can find a pattern, it'll be much easier than taking literally 7 derivatives, right? Getting up to the 7th term. So then what is sine of 0?
0.
Now hold on, we're thinking about all of these. We have our f's and we have our f primes. We're going to have sine. F prime is cosine. What's f double prime?
Negative cosine.
What's f double prime?
Negative cosine.
Keep going.
Positive cosine.
Oh wait, didn't we stop at we trying hoping that we'd find a pattern?
Yeah. Code. Oh, there's a sign.
So what's sine of 0?
0.
0. What's cosine of 0?
1.
What's 1 over 1 factorial? 1 what?
X.
Plus, what's negative sine of 0?
0.
Over, it doesn't matter, right?
0.
What's
-1.
negative cosine of 0 is -1 all over.
-1/6.
1/6. 3 factorial. X cubed.
We'll be we didn't keep going.
Plus 0.
It's just.
Wouldn't it be plus 0?
Yeah.
You guys see the pattern?
Yes.
The signs are gonna alternate, and you're only gonna have the odd degrees because every other one, you're taking it based on sine of 0, which is always 0, right? Which is how we get our x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. How long do we keep doing this for?
Forever.
Nope, because it said 7th degree, but you could keep doing it if there wasn't like a set stopping place. Does that make sense? So this would be the 7th degree Taylor polynomial for sine, which we could build ourselves off of this formula right here. Does that make sense? What's different between the Taylor and the Maclaurin?
I mean, it's nothing really, it's just plus minus 0 every time. They just-
Who's more general and who's more specific?
Taylor's general.
Good. So, Maclaurin is to Taylor like Rolls is to MBT, true? Does that make sense? Rolls is a specific case. Rolls is when you're talking about the derivative being guaranteed to be 0, whereas MBT is the general. It's just the slope's the secant line, and there must be a tangent line in between. Maclaurin is a special type of Taylor in that it's always centered at 0. True? Okay. You guys got the note at the bottom, yeah? Okay. So, find the Maclaurin polynomial degree n equals 5 for f of x equals sine of x. Then use the 5th degree Taylor or Maclaurin polynomial to approximate the value of sine of 0.1 using correct notation. Find the error. Okay, let's just start. What's the Maclaurin polynomial for n equals 5 of sine?
You start at 0.
Start at 0? We could. Didn't we just do all this work though? So let's use it.
Welcome back.
So the 5th degree is going to be x minus x cubed over 3 factorial. Could we build it? Yes, but didn't we just build it? So let's go ahead and just use it. There's our 5th degree. How do we know it's the 5th degree? Because it stops at x to the 5th. Be careful. Be careful. We'll have to talk about, will you ever be stopping at a degree that is not what you see? But for right now, that would be when x minus 0 is being raised to the 5th. That is that term, so we're good. Now it says use it to approximate what?
5.1.
Does this notation make sense?
No.
The 5th degree Taylor or Maclaurin polynomial, which is a Taylor polynomial, will approximate sine of 0.1. Does that make sense?
Yeah.
Okay. So then I approximate by plugging in. Find the error for your approximation. What does that mean?
The difference between the actual and the real.
Does that make sense notation-wise? When we were doing the alternating series estimation there, remember we'd have we'd have the actual sum. In this case, we have the actual sine of 0.1 minus the approximation that we can find from the 5th degree Maclaurin polynomial. Determine an interval in which sine of 0.1 could actually live. Interesting. Actually live. Okay. You guys plug it in? Make sure you're in radians, unlike all of my calculators, because pre-cal uses them. Yes, it might be nice to know at least some of the basic, the smaller factorials up to like, I don't know, 6 or 7. That might be helpful.
What the hell is this?
Yeah.
5 factorial is 120, yeah?
Yes.
It's,
How'd you get that?
Well, I typed in the exact sign of 0.1, I didn't type in the approximate decimal.
What do you mean?
So I think yours is probably rounded that last decimal place, and that might have messed it up.
But could you have just done sign of 0.1 minus that, or is?
Yeah, minus, and then make sure you put this all in parentheses.
Yeah.
we
that's
should
the-
have signed it.
Are you in radians?
Because we put, like,
Okay.
Okay. Now it says finally, oh, no, find the error, determine an interval in which sine of 0.1 could actually live.
Good.
What's an interval in which sine of 0.1 could actually live?
would you do +1 -1 of, +1 from left? Or plus +1
Perfect, thank you. Just the button. You guys good? Like, remember how we would take the absolute value into the negative error, the positive error, then just add the P5? Does that make sense? Mm-hmm. Mm-hmm. So we... Oh, I should have separated my P5, shouldn't I? Fascinating. I'll do this.
Y'all look into the funny ones.
Like 1/6. Okay, good.
Yeah, no.
It depends on my fundraisers.
No. For old people, no.
She's doing
Right, those?
No, but it was going.
Right, Noah?
Huh?
Right?
Right.
Thank you. Noah gets it. Noah got it. Yes, it is.
Yeah, I'll just wait.
Well, make sure I learn something.
Hold on, do you have the same thing I did?
Well, what?
You're getting the same number.
Well, yeah, the area is ridiculous. Oh, yeah, I got you. 3.
Oh, wait.
It's the same number.
I think I put both in negatives. But do you guys get the same number in either one? Positive or negative? Oh, nope. 9, 9, 8, 3, 3, 4, 1, 6.
5.
For the first one, I'm gonna do a different one. 0.0.
Oh, that's amazing.
Wait, what? 6, 5. I got the same thing.
How'd you get, why don't you have 0 then?
I got 6, 6 for one, 6, 7 for the other.
Yeah, same here. But it's point 0.
0.9.
Not,
Oh, I didn't put the 0. Thank you.
yeah, so that there's about 5.
Why are they saying it's pretty cool?
Because it's pretty accurate.
It's stinking accurate.
Wow.
Something accurate to like the million and stuff.
And that's only with the 5th degree.
Not even a nano. It's more accurate than.
However, 0.1 is still what?
No.
Pretty close to 0,
Mhm.
right? It's still pretty close to 0. So if we were to go 0.2, 0.3, 0.4, but still the idea is, yes, it's maybe not exactly on it, because it needs more terms to get closer and closer and closer converged. Closer and closer and closer. However, the idea is that it's stinking accurate. Lucy, what's up, kid?
When we're plugging, when we're getting like the first alignments with like 6 and 5, for us, are we just always plugging in 0 to get to the curve?
This one said McLaren, and so since it said McLaren, that's the specially defined one where we are centered at 0.
Yeah.
And since the direction over here said Taylor, but said, oops, sorry, said Taylor, but at 0, then they didn't actually say McLaren, but they meant it.
Yeah.
Now, if they were to say something like centered at 3, we'd have to, well, change things up quite a bit.
Thank you.
How about this one? Ready, set, go.
This makes me I think it makes you more uncomfortable when I do this, and when you do that.
Could you try to do a few and see if you can find a pattern and then cheat the rest? Yeah?
I'm still writing the question. I'm not epilepsy design.
Or maybe you're gonna have to find all of them.
All of them.
Well, if I'm-
Every accent.
Every accent.
That's unusual.
You should have a claim for
Sorry, for 2 seconds.
you know how many
Are you actually?
Yeah.
Yes.
I was supposed to say something stupid, but yeah.
Okay, just say it.
Yeah, I'm not supposed to say that.
What?
I won't say that. Wait, what's a double prime?
Plus.
It's a new one, right?
Wait, so there's people drawing.
I messed up.
Unless you find a pattern.
Oh, there's a pattern.
There.
See it? There is. The sign at this one. So it swaps. It goes positive, negative, positive. Okay.
I got compulsion.
So maybe I'll have two negatives.
You guys do the power rule and bring down? Gotta watch out for this pattern.
Wait, why?
Because you gotta take x to the negative 2's derivative. Yeah.
Memo.
Oh, I just.
Are the
Yeah, those aren't covered. Those are not covered.
Good.
Yeah.
Told you it might be helpful to step in.
Oh, really? Derivatives in one. So second, third term. So we go with third. Just do 2, 3, 4, 5, 6, and 5. 1, 2, 6, 3.
With an alternator, right? If you were to do the nth term, you'd have to have a negative 1 to the n, to the n plus 1.
Why weren't the factorials on the bottom cancel out with ones on top?
Oh, I was showing you the bottoms. Sorry, I was showing you the tops. Good, because of good. And then that one's not gonna matter.
Well, you already did it too.
Wait.
You did it to the side. Oh, yeah.
I thought you guys were seeing the pattern of those. I apologize.
Oh, so those all back.
1, 1, 2, 6, 24, and 120 are the factorials, but they're one off what the formula has. Then it would end up being still x minus 1, still minus, but the 1 and the 2, just 2 is left, so it's going to be x minus 1 squared over 2. The 2 factorial and everything but the 3 is going to cancel. So x minus 1 cubed over 3. 3 factorial, everything will cancel but the 4. 4 factorial, everything will cancel but the 5. Because remember, this is 1, 2, 3, 4, and then 5. So the 4 and below all cancel out, just the 5 is left.
You forgot the fourth superscript and the fourth one. You forgot the fourth power.
Thank you.
Good night. Oh, that's interesting.
Do you think LN has a special pattern too, not just sign? Looks like it.
Oh,
Guess who else does? Hold the
yes.
sign, and e to the x, and 1 over 1 minus x. All right, I'll see you tomorrow. 10.1 has a fully ready to grade, which it should have been today. 10.2, you can get started and playing with. Bye, guys. Homework sheets online. Bye.